Hello, and welcome to today's lesson in quantitative reasoning. We're working with the idea of percent, tax, discounts, things like that in our finance unit. And what we're going to look at today is how to measure percent change. And the big idea here is the difference between absolute change and relative change. Relative change can be then turned to a percent. Absolute change is just, how many dollars different was it? And we're going to talk about that in this lesson here. So let's see if I can figure out how to move the slide. All right, this is a slide that was coming as part of your text. So here are the objectives. Calculate absolute and relative change. Absolute is just the dollar amount. I got a raise from $12 an hour to $13 an hour. The absolute change is $1. The relative change would be $1 divided by 12, the original 12. So it gives you more of a ratio, and then you usually multiply that by 100 to get a percent. So percent increase or percent decrease is the absolute change divided by the original amount, which gives you the relative change times 100. And then we're going to find a percent increase or decrease by knowing some information about a problem. Now, all of these show up in the context of word problems. So if you I don't like word problems, you've got to get past that. The math isn't more difficult. It's usually actually a tad easier than some of the kind of hardcore stuff we make you do in just developing skills. You read the problem and you extract the information and then you apply the procedure. So don't let that send your brain into panic mode. All right. So absolute and relative change. Given the starting and final values of a quantity. Okay, the example I used in the introduction was you were making $12 an hour and you got a raise to $13 an hour. So this is the starting quantity. This is the final value of the quantity. Original or new are another way to look at that. Original and new. So to get the absolute change, you always do end minus beginning. That's true when you take science classes. That's true when you do all kinds of things. It's end minus beginning. That gives you the amount of the change. Now, if that end is smaller than the beginning, you will get a negative value. Sometimes quantities decrease instead of increase. If they increase, you get a positive. If they decrease, you get a negative. We do work with negative numbers in life. So the relative change will be this answer you get, the difference from the end amount minus the beginning amount divided by, and this is the part, I don't know why students always mess this up, especially when you can write it down and have it in front of you. You divide by the original amount, the initial value, not the end. So if you wanted to know the relative change when you got a $1 raise, you now make 13, that's the new value, that's the final value, minus the 12 is the initial, and you would divide by the 12. You divide by the number that was subtracted, assuming you did that correctly. That gives you the relative change relative to the number 1. We like to deal in percentages because it gives us nicer wholer numbers to look at rather than decimals all the time. We would almost always be dealing with some, a number followed by a bunch of decimals if we didn't use percent. But often we take a percent and then we round to the nearest percent and we have nice integers to work with. And it also normalized. So this is normalized to the amount 1. 13 minus 12, it's 1/12. And if you did 1/12 in your calculator, you do 1/12 is just 1 divided by 12. That fraction bar, you get 0.0833, and that 3 goes on forever. So that's the relative change. But to get that as a percent, we multiply it times 100. And that always moves our decimal. That'll move our decimal 2 to the right. You can also do it in your calculator. Nobody's taking your calculator away. Don't be too lazy to get the calculator. Now that 3 goes on forever. Now if we were told to round to the nearest percent, we would say 8. If we were told to round to the nearest tenth of a percent, and notice you round to the percent after you find the percent. You don't round here and then find the percent. If you're dealing with a percent and they say round to the nearest percent, it's 8. If you rounded here, you'd get 0. You have to find the percent first and then round that. That's buried in the words in the instruction. They said to the nearest tenth of a percent, you would say 8.3%. They said to the nearest 100th, you'd say 8.33%, so on. Most of the time it's tenth or 100th at the most. Often we use just the nearest percent, sometimes the nearest tenth. So follow the instructions. Rounding is a skill you're supposed to have from prior coursework. If you need help with that, let me know. All right, so let's move on. So that's our example of you were making $12 an hour and now you make $13. This may be a bit dated. I don't remember what minimum wage is. Hopefully it's more than $12 an hour now. But if you were making 12 and then you're making 13, the percent increase is 8.3%. Often in industry, when you're given a raise, they don't tell you the amount of the raise straight out. What they say is, congratulations, you've been given a 3% raise or a 2% raise, or the biggest I ever got was like an 11% raise. They tell you as a percent, and then somewhere in the paperwork it also says what amount that is. But so understanding this is important to kind of everyday existence and if you're working at all. Okay, so this is what we just said. To find the absolute change, it's the final value minus the initial value. You have to make sure it's end minus beginning. New minus old is the other way to think of that. That's the new amount minus the old amount. Don't turn that around. I don't know why students turn that around. It's so frustrating. Write it down and follow the instructions. You can tell which one's the new one and which one's the original one. So then you find the absolute. So this is the absolute change, the amount of the change. Then you divide that by the initial or the old. Don't divide it by the new. That's a common mistake. Then to get that, then you change that number to a percent by multiplying it by 100, because this gives you a relative change. This relative change will be based on the number 1. You want to base it on the number 100 because we tend to compare things in percents. So it doesn't tell us how much it changed once you have the percent. It doesn't tell you what the absolute change was, but we can work this backwards, and we will. You can tell it was an increase if the percent is positive, if the percent change is positive, because percent changes can be negative. This absolute change can be negative. So that is how you do that. These instructions are important. So the value of a car dropped from $7,400 to $6,800 over the last year. What is the percent change? The first thing you want to do is identify from to. The from was what it was originally. That's the old value. That's the final value. Sorry, that's the initial value. Whoa, bad math teacher. Initial value. The 2 is the final value or the new value. So it is now $6,800. So you're saying, did it go up or go down? It went down. So the lower number is your final value. So you take the 6,800 minus the 7,400. So keep in mind from to. From tells you what the initial, the number after from is the initial, the number after the 2 is the final. So you do the difference, subtract that. Everybody should be able to do that. You have a calculator. Notice you get a negative number. That's important. So they say they take the absolute. Okay, so they make an absolute value out of that and just take the $600. That's okay as long as you use the word decrease here. I kind of like to do the percent. If you're just doing percent change, I like to do the negative 600 divided by 7. Then that gives me a negative 8.1%, and that tells me it goes down. But if you just take the amount and tell me it was a decrease, and you know that because that's negative, and just give me the positive percent, that's fine. That might be the way your book does it in the homework. Pay attention to that. If they say they take the absolute value on the homework, do it that way, okay? And that's only going to be an issue if the final value is less than the initial value. So it's new minus old. The from gives you the old. The to gives you the new, or the final. Keep that in mind. So that works backwards. All right, so here's another example. Amelia's salary was $72,000 in 2015 and $76,000 in 2018. So 2015 comes before 2018. What was the relative change? So this is the final. It's a later year, and this is the initial. So if amounts are given to you associated with years, the latest year is the final. The beginning year is the initial. So you label those. I would write that down on a piece of paper. I know you're doing your homework online, and it's not a video game. You should be writing on paper. So you write down initial, you write down the two numbers and then decide if they're initial or final and label them on your paper. So we compute the salary change and we get it was $2,000. And that was an increase. We can see, oh, wait a minute, they had a mistake here. That should either be a 72, or this, actually what they did was they did the problem like this, 74,000. Okay, so we'll do the problem the way they did because the rest of it's consistent. Let's say her initial is 74,000. That's a mistake. That should have been a 72 if up here was correct, but we'll change the number up there. So I get the new, or the final, minus the initial. Initial means beginning, at the time we start looking, that kind of thing. Final minus initial, and I get $2,000. That's a positive number anyway. So it's an increase. It's clear that it's an increase. So I do 2,000 divided by 76,000. That's a funny, that is the relative change. If they ask it as a percent, you're going to multiply that number by 100. Oh, they didn't do that in this slide, so I'm going to go back. So if you want that as so this is the relative change. Relative change in this text is not multiplied by 100, but if you want the percent increase, you would do, if it asked you for the percent increase, you would multiply that relative change times 100. So first you find the relative change, then you multiply it by 100. That's a 2.6% increase. That over 3 years, that's not great, but hey, it's better than not getting an increase. All right. Percent literally means per 100, parts per 100, as if there had been 100 is another way to think of it. 40% means 40 out of every 100. If you were counting M&Ms and determined that that 4 out of every 10 of them were green, that would have meant 40 out of every 100 of them were green. You would expect that if you counted 100 and you find about 40 green ones. Talk about that a little in statistics, theoretical versus actual. But 80 out of 200 is the same as 40 out of 100. 10 out of 25 is the same as 40 out of 100. All of these are equivalent fractions. And if you look here, 200 is on the bottom here, and 25. There are 25 times 8 is 200. So, and 10 times 8 is 80. So if you had so that's why they're equivalent. If I multiply the top of this times the bottom of that times the top of that, I'll get the same number. Okay, they are equivalent. But the equivalent fraction we're most interested in percents is the one out of 100. So we can take any fraction and write it as an equivalent fraction out of 100. Now, sometimes this number on top might be a decimal, might be, 37.23. They don't always come out integers if we're forcing it to be over 100. In this case, it is 40 out of 100. So percent is part over whole. We talked about this in class last week. You should know that. This will be a good review of it. So if you hear that tuition is expected to increase by 7% next year, that's not what I'm hearing, but just pretend. And tuition was $1,200 per quarter, so this must be a college that uses quarters, or some of those around here. What will it be next year? And so if they gave you the tuition per quarter, you're trying to find out the new tuition per quarter. Don't worry about multiplying by 4 unless they ask you for the years. So this should say quarters tuition if they're being technically correct there. So in the news, you hear tuition is expected to increase by 7% next year. If tuition was $1,200 per quarter, what will it be next year? 7%. So increase means I would expect it to be more than, you expect the answer to be more than 1,200. Sometimes writing that down somewhere is helpful, because then when you get your final answer, you can look and see if it makes sense. So what we did first was, there's 2 ways to do this. You can find 7% of 1,200 and add it to the 1,200. We did that in class. But if it's going to be 7% more, it's 100% plus 7%. So it's 107% of the $1,200. That word of means multiply. 107% gets written as 107 over 100. That's 107%. Whenever you see this percent sign, you can just change it to that. Now, some of you are looking at that and going, it's a fraction. I don't like fractions. Easy. It's easy. It always works this way. Top times top, bottom times bottom. You say, but there's no bottom. That's fine. There's a 1 here fractions, when you multiply them, top times top, bottom times bottom, if you have an integer or a number that does not have a denominator, any number that does not have a denominator, doesn't need to be an integer, you just multiply by the top because the bottom is assumed to be a 1 and it won't change the bottom. So you do 1,200 times 107 divided by 100, and that will get you 1,284. That is what you do in your calculator to evaluate that. So you just change the percentage to a fraction out of 100. The number in front of the percent sign goes on top, 100 goes on the bottom. That's what the percent sign tells you. And that is how I can do that one in one step. Now in the next slide, we're going to see another method. I could first just find out the amount of the increase. This is the amount of the increase. So it went up by $84. And then I can just add this to the original plus the increase will give me the final. Some of you will rather do it this way because you see what's happening better. Doesn't matter to me which way you do it. So this question goes back to what we did before with relative change and then turns it to a percent. A quantity increases from 144 to 168. This is the initial. It started at 144. It ended at 168. This is the final. Round your answer to the nearest whole percent. So first you're going to find the relative. You're going to find the absolute increase. This is the absolute increase right here, 24. You subtract 168 minus 144. Absolute increase. Or the amount of the increase. If this was dollars, this would be $24. So when you find the absolute change, it's in the same units as you started with. Let's say it's increased from 144 students to 168 students. This 24 would be students. But once you change it to a percent, this was 24 students. This was also 144 students. This makes a unitless ratio. Okay, students divided by students will cross out and give you a 1 if you look at the algebra of it. But if you have students on the top of your fraction and the same students on the bottom, when you multiply by 100, you get a dimensionless ratio. You can't say 17 students. You can't say, it's a 17%. 17% you could say of the students. You could add a label so you know what it was a percentage of. But this is actually a dimensionless unit. And if you did a little dimensional analysis in chemistry or in maybe a prior course, you'd see that when you have students divided by students, students on the top of a fraction, students on the bottom, it's something divided by itself and it just gives you a 1. That's what that means. Just like if you have grams divided by grams in chemistry, they cross each other out. When you change gallons to quarts, you do some crossing out. You've done this when you do unit conversions. But the point is, the absolute increase has a label that's the same as the original label. Now, we had no original label here. If it had been students, it would be 24 students there. Then you take that 24, the change, 168 minus final minus initial. So you subtracted the 144. That's the number that goes on the bottom here. So you do that 24 divided by 144, which is the initial, then multiply times 100. You get 16.67. You're going to round this to the nearest whole percent. Well, let's see. The whole percent would be the ones place. So I have 16.67. So I don't want anything written. I'm just going to keep my numbers to the left of that line there. But I have to decide what this number does, the last one. It's a 6. Does it stay a 6 or does it go up to a 7? To tell that, I look at the first number I'm going to leave out, the 6 over here. If that's 5 or bigger, it's 5, 6, 7, 8, or 9, you're going to move this one up by 1. Because what you're saying is 16.6 is closer to 17 than it is to 16. Some people have you round up at the 5. Some people have you round down. I think this book rounds up. Well, I'll check on that. Let me know if you have any trouble getting right answers from that. But most conventions I've seen is 0, 1, 2, 3, and 4 stay the same. So if this were a 4 here, you'd get 16. But because it's a 6, you're going to get 17%. Round to the nearest whole percent. don't let the rounding be the thing that makes you get the problems wrong in the homework. That quite often happens. It's the prior skills that really catch us. So we pay attention to the new stuff. Got to pay attention to remembering that too. If you want some practice on that, I certainly can generate some problems for you to do on your own with answers for that. So that was 17%. Another example, car dealership is advertising each car will be discounted $2,500 for new customers. If the car was originally listed at $32,200, what is the percent decrease? So decrease tells you that the new price is going to be less. You're going to have to, that's all that word decrease means. Round your answer to the nearest whole percent. So this, they gave you the absolute change. They gave that to you. It's really a negative $2,500, but we can just use the positive and say it's an 8% decrease when we're done. So that's the change. They already did. This is the value of the final minus the initial. And it's actually going to be a negative number. So this was the initial 32,200. The final will be less than that. We don't even need to find that right now, although that could be another, I'll answer that question in a minute too. So you already have the absolute change. They told you how much money is coming off, not the percent that's coming off. So you do that absolute change divided by the original price. And you do need the original price to do this, times 100. And you get 7.76%, or about 8%. Now, this would be useful if you were comparing, if one car dealer was saying how much of a discount they'll give you, and another car dealer was saying we'll give you 10% off. Then you know that 10% off might be a better deal because this is only 8% off. So after you do, so you would have gotten, if you didn't multiply by 100, if you just did 2,500 over 32,200, you would have got 0.0776. If you rounded your answer to the nearest whole percent there, you would have got 0. You have to multiply by 100. When it says round your answer to the nearest whole percent, it means after multiplying by 100. That's a mistake I've seen more often than I would have expected. And I just want to point that out. Okay, so you got to look at what they gave you. That's not the new price. That $2,500 is how much money they'll take off. That's the amount of the discount that makes it an absolute change. All right, so then, I told you I was going to do one more thing there. So for this one, so what's the new price? Well, to find the new price, if they give you the absolute change, the new price is pretty easy to find. It's just 32. They're going to take off 2,500 minus 2,500. So how you read these problems tells you how to answer you have to read them and understand what the numbers mean. That just means how much they'll take off. That makes this a very easy find the new price of the car, $29,700. Okay? So if they tell you how much the discount is in dollars, you just subtract it from the dollars you started with. All right, percent increase. People in the media often talk about how much an amount has increased or decreased over time. They express this as a percent. To find the percent increase, first we find the amount of the increase, that's that absolute change, and then the difference of the final value and the initial value. Then we find the percent. So again, we are just finding the amount of the increase, which is the final minus the initial. It doesn't matter if the amount went up or down. You find the amount of the change and divide it by the initial value and then multiply by 100. So let's see what we have for examples here. Second-year teachers in a city make $48,600 a year. Third-year teachers make $49,700. What is the percent increase for an additional year of teaching? This is often how teachers' salaries are set up. There's a grid with years of experience and degrees going across the top. But round your answer to 2 decimal places. So you're asked to find the percent increase. You take the new value, 49,700. So since it's an increase, you're going to do the higher value minus the lower. They're asking you for the percent increase in this case. And you get $1,100. That is the absolute change. Now they're asking you to find what percent. They turn it into an equation. I'm going to tell you that there's no reason to do that, but this is really what you're doing. You're doing 48,600 times some percent equals $1,100. What percent of 48,600 is 1,100 is what you're finding. what you end up doing to solve this is you do 1100, which is the change, the absolute change, divided by the original amount. So this has to be the initial amount. That's the key. Which number do you use? Once you find the absolute change, and then you multiply that by 100. So this would have gave you P is 0.02226, and you multiply that by 100. Continue to do it this way. Don't let this confuse you if writing the equation confuses you. Some of you may see it better this way, though. You take the original amount times the percent increase, and it tells you how much the increase is. So a family's heating bill in March is $256. Their bill in April is $192. It must have been a little warmer in April. What is the percent decrease in the family's bill? So the oldest, so I'm going to do 192 minus 256. I know they don't pay attention to the sign, but I like to. And when I do that, I get 64, negative 64. Now they just take the absolute value of that and use 64. Don't start messing around with changing don't do that. Always do the final minus the initial, and then if you already know it's a decrease, you can ignore the negative. This is one of the few cases in math where you can ignore the negative. Some of you like to ignore them all the time. Again, they wrote, okay, so the original was 256. 256 times P equals 64. What percent of 256 will give me a $64 change? I'm going to tell you that it's just as easy to do 64 divided by 256, and you get 0.25. And when you multiply 0.25 times 100, you get 25%. All right, so there's a lot of examples there of percent increase and percent decrease. Hopefully you'll have seen some of these in class too. All right, thank you for joining.